Hi, today we are going to discuss about the speed of image in a spherical mirror. Speed of images in spherical mirrors. We all know that in case of a plane mirror, if we are standing at a distance of x centimeter, we will have image at a distance of x centimeter also. And also we all know that the velocity with which an object is approaching is v0 towards a plane mirror. It will have a velocity, the image will also have a velocity vi, which will be opposite to the direction of that of the object. So what about the case of a spherical mirror? In case of a spherical mirror, first of all, we are considering a concave mirror, which we are generally used to derive the formula. So here we have a concave mirror, and suppose the object is moving towards the mirror with a speed of VO meter per second. Then we have to find the speed of the image VI with respect to the mirror. Here the velocity VO is the velocity of the object with respect to mirror, and VI is the velocity of the image with respect to the mirror. So we have to find out, first of all, we have to write down the mirror formula, which is 1 by V plus 1 by U is equal to 1 by F. So when we differentiate this V and U with respect to time, we are differentiating with respect to time, we will get V raised to minus 1. We are just rearranging it for the sake of easy differentiation. V raised to minus 1 plus U raised to minus 1 is equal to F raised to minus 1, and we are differentiating it, we will get V raised to minus 2 divided by V raised to 2 minus 1 into V raised to minus 2 plus minus 1 into U raised to minus 2. Since the focal length of the mirror is remaining a constant, the derivative of this value will be equal to 0. So it will be minus 1 divided by V square dV divided by dt. Oh sorry, I have so when we are differentiating V raised to minus 1 with respect to time, we will get, first we have to differentiate V with respect to V. That is, we have to apply the chain rule, which means dV raised to minus 1 divided by dV into dV divided by dt. So it will become minus 1 into V raised to minus 1 into dV divided by dt, which is equal to minus 1 divided by V square dV divided by dt. So differentiating this equation, we will get 1 by V square minus 1 by V square dV divided by dt plus minus 1 divided by U square du divided by dt is equal to 0. Since the focal length is constant, the derivative of focal length will be, with respect to time, will be 0. So rearranging this formula, we will get minus 1 divided by V square dV divided by dt equal to 1 divided by U square du divided by dt. We are substituting dV divided by dt as velocity of image with respect to mirror, and we are substituting du divided by dt as velocity of object with respect to mirror. So we will get minus 1 divided by V square velocity of image equal to 1 divided by U square velocity of object with respect to mirror. So rearranging, we will get velocity of the image will be equal to minus V square divided by U square of velocity of object with respect to mirror. So here when we substitute, this is the equation for finding finding the relation between velocity of image and the velocity of object in case of a spherical mirror. Here, whatever be the sign we are using for V and U, there will be no change in case of the whatever sign, whether the V is negative, whether U is negative. Since we are using the square terms, there will be literally no change in case of the velocity of the image and velocity of the object. And also we have to consider that the velocity of the image is opposite to that of the velocity of object. This negative sign indicates that. This negative sign indicates it is opposite in direction. That's what this is using. So we let us solve a problem right here. A spherical mirror of image at a distance 10 centimeter from an object at a distance 30 centimeter. A spherical mirror form an image at a distance 10 centimeter of an object at a distance 30 centimeter from the mirror. If the object starts moving with a velocity 9 centimeter per second, find the velocity of the image. Here the image distance is given, V is given. Here what is given? At a distance 30 centimeter from the mirror. And also the distance to the object U is also given, which is equal to 10 centimeter. Here the mirror is not specified. Whether the mirror is convex or whether the mirror is concave, I have said earlier that whether the V and U have negative or either positive values, it does not depend on the result of using this equation, which is velocity of the image is equal to minus V square divided by U square V of object. So we are directly substituting the values of the velocity of the object. We are directly substituting the image at a distance 10 centimeter. Hence the value of V will be equal to 10 centimeter. And object is at a distance 30 centimeter. Hence the distance will be equal to 30 centimeter. Velocity of the object will be equal to 30 centimeter. And if the object is starting moving with a velocity 9 meter per second, hence the velocity of the object will be here. It is 9 centimeter per second. Also note down that if we are having a same quantities, we are taking the ratio of the same quantities, we have to note down that the ratio will be same if we change it into meter or centimeter. So here the velocity of the value of V and U are both given in centimeter. Whether we convert it into meter and then find the result, the ratio will be the same. So we don't have to change the unit, so we have to directly substitute the values. So it will be minus into the value of V square, 10 square divided by 30 square into velocity of the object, which is equal to 9 centimeter. So it is equal to minus 100 divided by 900 into 9, which is equal to minus 1 centimeter per second. This is the velocity of the image. Hence the velocity of the image will be equal to opposite to that of the direction of that of object, and it will be 1 centimeter per second at this instant, which means the velocity of the image is not constant, it is changing as the distance changes. So we have to note down also that whether an object is approaching, the image velocity does not remain constant, it is continuously changing. So hope you all enjoy a good class. Thank you. We will meet again.